States of matter. Learning objectives. Matter. Atoms and molecules. Solid, liquid, and gas. Changing states of matter. Physical and chemical change. Matter. Anything around us is matter. Any substance, called matter, can exist as a solid material, liquid or gas. These three different forms are called states. Matter can change its state when heated or cooled. Atoms and molecules. All matters like paper, pencil and book are made of tiny particles. These tiny particles are called atoms. These atoms are the smallest particles of matter. We cannot see an atom with our naked eyes. What we do see are objects that have been formed because of different atoms combining together. All matters, solid, liquid or gas, are made of atoms. Two or more atoms combine to form molecules. A molecule is the smallest piece of a substance that has the same property as the entire substance. If the molecules are broken down, that piece will no longer be the same substance. Solid, liquid and gas. When something is solid, like copper, steel, rock, or ice, it is stiff. It does not change shape easily and it does not change size. In a solid, the molecules are closely bound to one another by molecular forces. A solid holds its shape and the volume of a solid is fixed by the shape of the solid. In fact, that is the definition of a solid, matter which has a definite volume and a definite shape. Solids have definite shape. Solid, liquid, gas. More about molecules. The molecules in a solid, though they vibrate, do not move very far. When they wiggle in place, they fit closely together and keep their position. Matter, when it is solid, usually does not take up as much space as matter in other states. The molecules are crowded together and do not move away from each other. They can jam into a smaller space. Solid molecules structure. Solid. In a liquid, the molecular forces are weaker than in a solid. A liquid takes the shape of its container with a free surface in a gravitational field. Regardless of gravity, a liquid has a fixed volume. A liquid like honey, cooking oil or water can flow and move. It changes shape easily and takes the shape of its container, though its size stays the same. The definition of a liquid is matter which has a definite volume and no definite shape. Liquid molecules structure. Liquid. Liquids behave this way because in a liquid, the molecules are packed loosely. In a liquid, matter can take up a bit more space than in a solid, because the molecules are free to move around. They can spread out more, but they do not go far from each other. In a gas, the molecular forces are very weak. A gas fills its container, taking both the shape and the volume of the container. A gas like oxygen, carbon dioxide or steam can expand to 5 any space it is in. If you spread air freshener, the escaping gas spreads everywhere in the room. Gas is matter which has no definite volume and no definite shape. Any smoke is considered as gas. The molecules in a gas move like crazy, bouncing balls everywhere. They do not have to stay close to one another. A gas takes up a great deal more space than a liquid or a solid. It takes up as much space as it is in. However, it can also be squeezed or compressed, unlike a liquid or a solid. Changing states of matter. Water is a very common kind of matter on Earth. Water molecules are made of 2 atoms of hydrogen and 1 atom of oxygen. Water is a solid, a liquid, and a gas at some very ordinary temperatures. Water is a good way to see the states of matter and how it changes. Freezing. The solid state of water is called ice. In ice, the molecules are wriggling in place. They keep their position as long as there is not too much heat. On a cold winter day or in a freezer, an ice cube keeps its shape. It is stiff and hard. Melting. When you heat the ice cube, the molecules start wriggling faster. Some of them start sliding. Because of gravity, they slide downwards to the bottom of the pan. Ice cube is turning into a liquid called water. Evaporation. Now ice has changed state. You can make the water change into another state. If you put the pan on the stove, you can make the molecules move faster. If they move fast enough, they will bounce right out of the liquid and into the air, spreading out in every direction. This is gas state of water, which is called the steam. The water has changed phase. It is still the same kind of matter. Ice cubes in pan. Heating ice cubes in pan. Water vapor from pan. Condensation. This water state can be reversed. Let's see how it reverses. You cannot see steam. Water droplets in the steam lose some heat when they come in contact with cold surface. Hence vapor changes into liquid. Condensation is the change of state from gas to liquid. Likewise, you can change water into ice. Put the water in the freezer. It will lose some heat, its molecules will slow down, and it will freeze. Expansion and contraction. When you heat a substance, its particles or molecules get energy and begin moving away from each other. This is expansion. For instance, when you try to open a bottle of jam with a metal lid, it is not opened easily. As the lid heats up lightly, the metal lid expands and loosens its grip on the bottle and can be opened. When you cool a substance, its particles or molecules come closer and take less space. The substance contracts or shrinks. The phenomenon is known as contraction. For instance, if you keep an empty water bottle in the freeze for some hours, you will notice that it shrinks in and gets twisted. This occurs because of contraction of air inside the bottle. When the air cools down, the air particles come closer and take less space. As a result, the bottle becomes contracted. Reversible and irreversible change. The properties of a material can be changed. Some changes are reversible, while some irreversible. A reversible change is a change that can be reversed by returning to the original conditions. It is a temporary change. It might change how a material looks, but it doesn't create new materials. Melting is an example of a reversible change. For instance, melted butter can be changed back into solid butter by cooling. Melting butter is a reversible change. Freezing is a reversible change. For instance, you can freeze water to make ice cubes. The ice cubes can be changed back into water by keeping them out of the freezer. Melting butter is a reversible change. Boiling, evaporating and condensing are all examples of reversible changes. For instance, if you could capture all the steam from a boiling kettle, you could turn it back to water by cooling it. Notice a pool formed by rain. Once the sun comes out, the water in the pool will evaporate using heat from the sun after a while. If a change cannot be changed back again, it is called irreversible. For instance, you cannot change a bread back into its ingredients again. So, you can say that irreversible changes are permanent. New materials are always formed due to an irreversible change. Heating can cause an irreversible change. For example, you heat a raw egg to cook it. The cooked egg cannot be changed back to a raw egg again. Burning can also cause an irreversible change. When the wood is burnt, wood becomes ash and smoke. Now ash and smoke cannot be changed to wood again. Cooked egg is an irreversible change. Solids, liquids and gases dissolve in water. We have to know that substances like salt and sugar are soluble in water. This means their molecules have the space between the molecules of water. Put a few crystals of potassium permanganate to water. Observe how the potassium permanganate soluble spreads color in water. Potassium permanganate is soluble in water. Alcohol is another liquid that is miscible in water. Kerosene, however, cannot be dissolved in water and is known as immiscible. Potassium permanganate is soluble in water. Gases like oxygen, nitrogen, ammonia and carbon dioxide can dissolve in water. Fish and other animals that live in water breathe in the oxygen dissolved in water. Water in the oceans, rivers and lakes have dissolved oxygen and nitrogen. Fish breathing oxygen dissolved in water. Physical and chemical changes. Physical change. A change in the form of a substance, for instance, from solid to liquid or liquid to gas or solid to gas, without changing the chemical composition of the substance. Example, boiling of water and the melting of ice. Melting, freezing, heating, condensation. Chemical change. The change of a substance into another substance, by reorganization of the atoms, i.e. by the making and breaking of chemical bonds. In a chemical change, a chemical reaction takes place. Example, rusting of iron, burning of paper and the decomposition of water. Burning of paper. Differences between physical and chemical change. There are several differences between a physical and chemical changes in a matter or substance. A physical change in a substance does not change what the substance is. In a chemical change where there is a chemical reaction, a new substance is formed and energy is either given off or absorbed. Physical changes can be reversed, so it is temporary change, while chemical changes cannot be reversed, so it is a permanent change. Summary. Any substance, called matter, can exist as a solid material, liquid or gas. All matter like paper, pencil and book are made of tiny particles. These tiny particles are called atoms. A solid holds its shape and the volume of a solid is fixed by the shape of the solid. Water is a good way to see the states of matter and how it changes. The properties of a material can be changed. Some changes are reversible, while some irreversible. We have to know that substances like salt and sugar are soluble in water. Water in the oceans, rivers and lakes have dissolved oxygen and nitrogen. There are several differences between a physical and chemical change in a matter or substance. Keywords. Melting, the process whereby heat changes something from a solid to a liquid. Freezing, the withdrawal of heat to change something from a liquid to a solid. Condensation, the process of changing from a gaseous to a liquid or solid state. Evaporation, the process of becoming a vapor.